Example: determine the tension in each segment of the cable. Also, what is the dimension h? So we have two supports at point A and D and three cables from A to B, B to C, and C to D. And we need to find the value for the height at point B, which is h. And we have a concentrated load at 3 kilonewton at point B, 8 kilonewton at point C. For the support at A, we have two reactions. So A, we have TBA, the tension of cable BA, and at point D, we have tension CD. We will be using summation of moment at point A to find the value for TCD. And we have the ratio of the distances of CD along horizontal distance, which is 1.5 meter, and the height, which is equivalent to 2 meters. 1.5 times 2, that's 3. 2 meters times 2, that's 4. 4 squared plus 3 squared, and the square root of 4 squared plus 3 squared is equal to 5. Using summation of moment, so summation of moment at point A is equal to 0 with positive sign of using clockwise direction. So we have TBA, TCD. At point B, we have 3 kilonewton, and we multiplied by the distance 2 meters from B to A, which is 3 times 2, and the direction to A is clockwise direction, so that's positive. And point C, we have 8 kilonewton, and the direction is also positive, and the distance is 2 plus 2 or 4 meters. So plus 8 kilonewton times 4 meters for the distance, and we have the tension at CD, have the ratio at point D, and the component of TCD of X, and this will be TCD at Y. TCD of Y, and the distance is 1.5, 2.2, or 5.5 meters. This will be, and the direction is clockwise or counterclockwise direction, so that's negative TCDY, and the distance is 5.5 meters. And TCDX, and the direction is counterclockwise direction, so that's negative TCDX, and the distance is 2 meters. And equate that to 0. And to find the value of TCDX and TCDY, we're using the ratio and proportion. So TCD of X, and it is equivalent to the ratio, which is horizontal, so that's adjacent over hypotenuse, that's cosine, or this will be TCD cosine theta. And the ratio of that cosine theta, TCD and cosine theta is adjacent over hypotenuse, or 3 over 5. So that's 3 over 5. TCDY is equal to TCD, and that's sine theta, and that's opposite over hypotenuse, or 4 over 5. So TCD times 4 over 5. And we substitute the value of TCDX and TCDY. So this is 6 plus 32 minus TCDY, that's 4 over 5 TCD times 5.5 minus TCD of X, that's TCD 3 times, or 3 over 5. So this will be 3 over 5 TCD times 2, and equate that to 0. And simplify, 5.6 TCD is equal to 38, and tension at CD is equal to 6.79 kilonewton. At point C, at point C, we have this one, we have TBC and TCD. So we have and 8 kilonewton. So we have TBC and an angle of theta BC, and we have the value for TCD. So we have TCD is equal to 6.79 kilonewton, and the ratio is 3:4:5. Next, we will find the summation of forces. Summation of forces Fx is equal to 0. That's 3/5 of 6.79, and this one, the component, that's 4/5 4/5 times 6.79, and this will be TBC of y and TCB or TBC of x. So summation of forces along x, we have TBC of x and 3/5 times 6.79. So negative TBC of x plus 3/5 times 6.79 is equal to 0. And TBC of x is equal to TBC cosine theta BC. And TBCY is equal to TBC, and that's opposite over hypotenuse or sine theta. So this will be sine theta BC. So we have TBC of x and TCB or TBCY, and equate that to negative TBC of cosine theta BC plus 3/5 times 6.79, equate that to 0, or TBC is equal to 4.074 all over cosine of theta BC, and that's equation 1. Next, summation of forces along y is equal to 0. We have 4/5 times 6.79 minus 8 and plus TBCY, and equate that to 0. Change to 4/5 times 6.79 minus 8 plus TBCY is TBC sine theta BC, and equate that to 0. And we have TBC, and that's 2.568 all over sine theta BC, and that's equation number 2. Equate 1 and 2, so that's 4.074 or all over cosine theta BC is equal to 2.568 all over sine theta BC, and sine theta BC all over cosine theta BC is equal to 2.568 all over 4.74, and sine over cosine, that's tangent theta BC, and equivalent to 0.63, and theta BC is equal to inverse tangent of 0.63, and tangent theta BC or theta BC is equivalent to 32.3 degrees. So that's angle BC. At equation 1, TBC is equal to 4.074 all over cosine theta BC, and we have 4.074 all over cosine of theta BC, which is 32.3, so 32.3 degrees. Tension value for BC, that's 4.82 kilonewton, and that's tension. At point B, we have TBA and TBC and a concentrated load of 3 kilonewtons. So we have angle theta BA and angle 32.3 degrees, and the tension for BC is equivalent to 4.82 kilonewton. For the component of TBA, we have TBA of Y and TBA of X. And for TBC, which is 4.82 kilonewton, we have, this is adjacent, so that's cosine theta multiplied by 4.82, and this will be sine theta or 32.3 degrees and multiplied by 4.82 kilonewton. And summation of forces along X, that's equal to 0. We have at TBAY, and we're using sine theta BA, or TBA times sine theta BA, while TBA of X, that's TBA cosine theta BA. And summation of forces along X is equal to 0. We have negative TBA of X plus 4.82 times cosine of 32.2 or 32.3 degrees, and equate that to 0. And change TBA of X to TBA times cosine theta BA. Negative TBA of cosine theta BA plus 4.82 cosine 32.3 degrees, and equate that to 0. Or this will be TBA is equal to 4.074 divided by cosine theta BA, and this will be equation 1. And summation of forces along Y is equal to 0. We have TBA of sine theta BA, and that's positive, and minus 3 kilonewton, and we have negative of 4.82 multiplied by sine theta, which is 32.3 degrees, and it is equal to 0. And simplify, so TBA is equal to 5.57 all over sine BA, and that's equation number 2. Equate equation 1 and 2. Equate equation 1 and 2. So that's 4.074 divided by cosine theta of BA is equal to 5.57, and divide by sine BA. And simplify sine BA all over cosine BA is equal to 5.57 divided by 4.074 sine over cosine, that's tangent theta BA, and it is equal to 1.367, and our theta BA is equals to tangent negative 1 of 1.367, and the value is equivalent to 53.81 degrees. So that's theta BA. So we have now the value for theta at 1 is 1. So T of BA is equal to 4.074, and we divide by cosine theta BA, or cosine of 53.81 degrees, and the value for the tension cable BA is equal to 6.9 kilonewton, and that's tension. And to find the dimension H, we will have the value for theta. So this will be theta, and the value is equivalent to 53.81 degrees. And let's solve for H. So H over 2 is equivalent to tangent of 53.81 degrees, or H is equals to 2 times tangent of 53.81 degrees, and H is equal to 2.74 meter. So the value for H is equivalent to 2.74 meter.